You think Earth is your home? Wrong. Earth is just a grain of sand on a beach that stretches beyond imagination. And what I'm about to show you will completely shatter your understanding of where you actually live in this universe. Right now, at this very moment, you're hurtling through space at 1.3 million miles per hour. Not because of Earth's rotation, not because we're orbiting the sun, but because something absolutely massive is pulling our entire galaxy like a puppet on cosmic strings. Scientists discovered this in the 1970s, and what they found should honestly terrify and amaze you at the same time. Welcome to the Virgo supercluster, your real cosmic address. And here's why almost nobody talks about the most important structure in our corner of the universe. Let me ask you something. When you think about your place in the cosmos, you probably think Earth, solar system, Milky Way galaxy, right? But that's like saying you live on Main Street and completely ignoring that you're in a city, in a state, in a country. The Milky Way? That's just one galaxy among 100 billion galaxies in the observable universe. And here's where it gets absolutely wild. Our Milky Way galaxy, containing roughly 200 billion stars, is actually part of something called the local group. That's about 54 galaxies clustered together across 10 million light-years. Already mind-blowing. But the local group? It's basically just a small neighborhood in something incomprehensibly larger. The Virgo supercluster spans 110 million light-years across. Let me put that in perspective for you. Light travels at 186,282 miles per second. If you could travel at light speed, it would still take you 110 million years to cross from one end to the other. This single structure contains approximately 100 galaxy groups and clusters. We're talking about at least 47,000 galaxies, possibly more. And every single one of them is bound together by gravity into this cosmic web. Now here's where scientists had their minds completely blown in 2014. They discovered something even bigger. The Virgo supercluster itself is just a lobe of an even more massive structure called Laniakea, which means immeasurable heaven in Hawaiian. Laniakea contains 100,000 galaxies and spans 520 million light-years. But today we're focusing on Virgo because this is where the revolution in understanding cosmic structure actually began. The Virgo cluster sits at the heart of our supercluster, about 65 million light-years from Earth. It's the massive gravitational anchor pulling everything toward it, including our Milky Way. The French astronomer Charles Messier cataloged several of its galaxies back in the 18th century without even realizing they were part of one enormous structure. It wasn't until the 1950s that astronomers began understanding the true scale of what they were seeing. Here's the controversial part that most science communicators won't tell you. For decades, astronomers argued about whether these superclusters were even real structures or just optical illusions, random groupings that looked connected but weren't. Some scientists staked their entire careers on proving superclusters were meaningless. They were wrong. Dead wrong. Modern observations using spectroscopy and galaxy mapping prove that superclusters are absolutely real, gravitationally bound structures. The matter in the Virgo supercluster isn't randomly distributed. It forms filaments, sheets, and voids like a cosmic foam or spider web. Galaxies cluster along these filaments with enormous voids between them, some voids stretching 300 million light-years across with almost nothing inside. This discovery revolutionized cosmology because it revealed how matter organized itself after the Big Bang. About 13.8 billion years ago, the universe was nearly uniform, just hydrogen and helium with tiny density fluctuations. Over billions of years, gravity amplified these fluctuations. Denser regions pulled in more matter, creating the cosmic web we see today. The Virgo supercluster is direct evidence of this process. Scientists use the Virgo supercluster as a laboratory to test fundamental physics. Dark matter, that mysterious substance making up 27% of the universe's mass, reveals itself through how galaxies move within superclusters. The rotation speeds and gravitational effects we measured don't match the visible matter we see. Something invisible is out there, holding these structures together. Then there's dark energy, the even more mysterious force making up 68% of the universe, pushing everything apart and accelerating the universe's expansion. Here's something that should keep you awake at night. Eventually, Dark energy will overcome the gravity, holding superclusters together. Billions of years from now, the Virgo supercluster will dissolve, galaxies drifting apart into cosmic isolation. But right now, studying structures like Virgo helps astronomers map the large-scale structure of the universe with unprecedented precision. Projects like the Sloan Digital Sky Survey have mapped millions of galaxies, revealing the cosmic web in stunning detail. Each supercluster, each void, each filament tells us something about the fundamental forces governing reality. The Virgo supercluster also helps scientists understand galaxy evolution. Galaxies in dense cluster environments evolve differently than isolated galaxies. Collisions are more common. Gas gets stripped away. Star formation changes. By studying thousands of galaxies across different environments within Virgo, astronomers piece together the complete story of how galaxies live and die. This matters for understanding our own existence. The matter in your body, the calcium in your bones, the iron in your blood, was forged in stars that lived and died within structures like this. The cosmic web determined where stars formed, where galaxies emerged, and ultimately where planets capable of supporting life could exist. You are not just on Earth. You're on Earth, in the solar system, in the Milky Way galaxy, in the local group, in the Virgo supercluster, in the Laniakea supercluster, in the observable universe. That's your real address. And understanding each level of this cosmic hierarchy brings us closer to answering humanity's biggest questions about existence itself. So follow for more mind-bending cosmic revelations that'll change how you see your place in this universe. Now here's my question for you. If we're just a tiny speck in a structure this massive, and there are millions of similar superclusters out there, what are the chances we're actually alone in this universe?